everyone. Today we'll get familiar with various components used in circuits, from batteries to motors, and we'll go over the basics of circuits. So let's get started. Let's start with cells. Here I've got 3 cells that you'll generally find in your household. Let's read each of these cells. So the largest one is the D cell. Now, you'll see plus on one side and minus on the other side of the cell. And you'll see 1.5 volts written on it. Another thing that we need to read is alkaline. We need to make sure the cell that we are using is alkaline and not rechargeable. Now let's look at double A cell here. Again, every cell has a plus and a minus terminal, and this cell is also 1.5 volts, and we see alkaline here. So this is also an alkaline cell. And similarly, the third one is triple A. This is 1.5 volt cell as well, and it is an alkaline cell. All these cells that I have here of various sizes, D, AA, AAA, have similar voltages, about 1.5 volts. So this is called potential difference. We say the potential difference between the cells' terminals is about 1.5 volts. Now let's get the AA battery and insert it in the holder. Make sure the plus is on top of the plus marked on the holder. So now we need 2 alligator connectors for this. I chose a red alligator wire and a black alligator wire. Now the motor has 2 terminals. So the tip of the red alligator clip should touch one terminal here, and the tip of the black alligator clip should be clipped onto the other terminal of the motor. Now be careful that the tips of the red and the black clips don't touch each other. In case they do, that will cause a short circuit. Short circuit can cause the battery to heat up and catch fire. So make sure they're separated this way. And now the other end of the red wire is connected to the plus of the battery, and the other end of the black wire is connected to the minus of the battery. And you can see the motor running. So now let's connect our motor the other way. So let's switch the terminals. Such that the black wire is connected to the black wire is connected to the plus of the battery, and the red wire is now connected to the minus of the battery. And what happens? Do you see any change? You'll see that the motor spins the other way now. And now let's connect a buzzer. So let's connect a buzzer one way. So here is our buzzer. Let's bring our wires back. So we've got red alligator wire connected to the plus of the battery, and the black alligator wire connected to the minus of the battery. And now let's connect our buzzer. So let's start with the red alligator wire and connect it to the red wire of the buzzer, and the black alligator wire to the black wire of the buzzer, and you can see it, you can hear it buzzing. Now what if we switch the terminals. Let's connect it the other way around. What happens? So here, the black wire of the buzzer is now connected to the red alligator wire, that's plus of the battery, and the red wire from the buzzer is now connected to the minus of the battery. And you can't hear it buzzing. It doesn't work. So if you have a bulb, you can try connecting a bulb to your battery. So connect it one way and you'll see it light up. Switch the terminals and you'll still see it light up. So some components don't care about how you connect them to plus and minus of the battery, such as this bulb. They are said to have no polarity, while others like motor care. They spin in opposite directions. They are said to have polarity. Other components like LEDs work one way and not the other. They too have polarity. Or a buzzer here, you could hear it buzzing only when you connected the red wire to the plus of the battery and black to the minus. So this has polarity as well. So it's important to observe polarity in electronics. Our electric car can go backwards instead of forwards if we get polarity wrong. Let's move on to switches now. So when you wired up a motor to a 1.5 volts battery, you created a circuit. If you run through your circuit starting from any component, you'll always come back to the component you started with. This stands true no matter how complex your circuit gets. So this is a closed circuit. It's a complete circuit. Now let's open this circuit. Here, this is called an open circuit. Here, circuit is broken. So these are the two terms we are going to use often: closed circuit and open circuit. Now let's add another alligator wire between the motor and the battery, and we'll use this wire as a switch. So here I've got a yellow alligator wire and I connect it to one end of the motor. So now I've got 3 wires in this circuit. Now we are going to use this yellow wire as a switch. So now let's turn the switch on to run the motor. And turn the switch off to stop the motor. So what are we doing here? To turn the switch on, we just touch the tip of the yellow alligator wire to the tip of black wire, and we close the circuit. And to turn the switch off, we open the circuit. It's that simple. That's all a switch does. When we turn a switch on to turn on light in our house or a fan in our house, all that switch does is it closes the circuit. So you could add one of these switches to your circuit. It's got 2 terminals. Let's add it to our circuit. Let's connect one end to the yellow alligator wire and the other end to the black. And now, what happens when you turn it on? So when you turn it on, there is a metal plate within the switch which goes down, and it creates a contact between the yellow alligator wire and the black alligator wire. That closes the circuit. Let's turn it on. So there's a metal plate which has gone down and created a contact between these two clips, and the motor turns on. Now let's turn it off. To turn off the switch, when we turn it off, the metal plate goes up and the circuit is broken. So there's no contact between the yellow and the black alligator wires. So it works exactly the same way as the switch that we created. It turns the motor on by closing the circuit and turns it off by opening the circuit. Now let's do a fun experiment to see how different materials impact a circuit. So you'll need a piece of aluminum foil, a plastic straw or a plastic spoon, and graphite from your pencil. That's your pencil lead. Now can you add a piece of aluminum foil to your buzzer circuit and see what happens? Does it sound the same? Now replace it with a plastic straw and see what happens now. Now replace the plastic straw with graphite from your pencil to your buzzer circuit and see what happens now. Can you hear the buzzer? You can also try adding a piece of wood in between your circuit and see what happens. So what do you understand? Typically, metals are conductors. Most non-metals are not conductors. Are they insulators? So graphite is a non-metal which is a good conductor of electricity. So that's the reason that adding graphite from your pencil still made the buzzer sound. It closed the circuit. For now, think of air, glass, wood, and plastic as insulators. There is a limit to everything. Even air starts conducting electricity when potential is too high. That's what happens in lightning. You're done here for today. Now, once you're ready to pack up after working on your circuit, make sure you run through these checks. First is you need to disconnect the battery from the circuit. Do not leave your circuit connected. And remove your batteries from the holder and store them away from each other. The terminals should not touch. That will cause a short circuit. That's all for today, and we'll learn all about LEDs and resistors in the next lesson.